This video will be going over all of the geometry first semester exam review. Here on problem number 1, we have the M is the midpoint of AB. So the first thing I'm going to do here is draw a picture that kind of shows me what's happening here. So here's my segment. Here's M on AB, and M is the midpoint, so I'm going to put those little hash marks in. A to M is 3x plus 1, and M to B is 4x minus 3, and it says solve for x. Well, since this is a midpoint, I know that these two segments are the same, so we're going to set them equal to each other. 3x plus 1 equals 4x minus 3, and we'll solve for x. So here you can see the answer here is going to be 4. On the second one, we are told that the measure of angle B is 72. So this entire thing right here, this is 72. And I need to find what's just x. So this is just your basic angle subtraction. So 72 for the total. I'm already using up 31 degrees. Subtract these and we get that x is 41 degrees. 3 is similar, but you'll notice that we do have the box. So I know that if I were to add these two together, like take angle 3 plus angle 4, they're going to equal 90 degrees. So now let's see what they tell us. Angle 3 is 5x plus 6, and angle 4 is 6x plus 7. So if we just add these things together and set them equal to 90, we'll be able to get our answer. So angle 3 is 5x plus 6 plus angle 4, 6x plus 7, and that equals 90. Combine our like terms, 5x and 6x, that's 11x. 6 plus 7 is 13, and that equals 90. So subtract 13, we get 11x equals 77, and x is 7. Whoops, there you go. Next up for number 4, angle 1 is 3x plus 6. Angle 2 is 6x minus 6. And I do notice here that I've got two angles that are making a line. So this is a linear pair. And if we add them together, take 2 plus 1, they should be 180 degrees. So angle 2 is 6x minus 6. Angle 1 is 3x plus 6, and they would equal 180. So just like before, combine your like terms. So with the x's, we end up with 9x. And then negative 6 plus 6, well, that's 0, so those are gone. So 9x equals 180. Divide by 9, and x is 20. Next up, so I see this x, so I'm already on the lookout here for our vertical angles. So I know that angle 2 is going to also be 50 degrees. And then I know 1 and 3 will be the same because they're vertical. But the way we're going to find it here is we're going to concentrate just on a line. So for instance, these two added together would have to equal 180 degrees. So if I just take 180 minus 50, I get 130. So angle 1 is 130 and angle 3 is 130. 6 is the same idea, but we're going to have to solve for x. So angle 3 is 6x minus 2 and angle 4 is 5x plus 10. Since they're vertical angles, they equal each other. So we'll subtract the 5x. After this, we're going to add 2. And x is 12. Next up, we have 7. So on 7, you'll notice that we have the arrows, which tells me that we have parallel lines here. So here you have your parallel lines. The other two lines would be your transversals. I'm going to first start with this one, though, as the transversal. So when I look at the information that's here. I'm looking at like the 50 and the 75. And the first thing that my eyes notice is that 2 and 75 are vertical angles. So angle 2 is going to be 75 degrees. And then this would be because they're vertical angles. The next thing I notice is that 3 is sitting next to the 50, but there's really not enough information there for me to figure out what 3 is. So I'm going to kind of instead lean on this right here. So 2 and 3 are inside those parallel lines. They're on the same side of the transversal. These two are same side interior angles, and same side interior angles are supplementary. So angle 3 is going to be 180 minus 75, since I already know angle 2 was 75 degrees, making it 105 degrees. So angle 3 is 105 degrees because it is same side interior with angle 2. Next up, you have angle 1. So this is the last one we have to find, and angle 1, you might notice that it's inside this triangle, and we could work with that and, you know, use the whole idea that there's 180 degrees inside, do some subtraction, but it's going to take a little bit more work. The key here is that you notice how you can use the 50. So if you look here, 50 degrees is made by that parallel line, and then this would be like my new transversal. If I come to angle 1 is made by the other parallel line, and then still this same transversal. This makes 50 degrees and angle 1 corresponding angles, and therefore they would be congruent. So angle 1 is 50 degrees because it's corresponding with 50 degrees. Next up, the measure of 3 angles of a triangle are represented by 2x plus 15, x plus 20, and 3x plus 25. Find the value of x, and then find the 3 angles, but list them in order of smallest to largest. So in this case, we have a triangle where each of the angles is given to us as an algebraic expression. So if I were solving this, I wouldn't have to draw this picture. I'm just doing for the sake of you seeing what's going on here. So I know that if I take all 3 angles in a triangle and add them together, it should give me 180 degrees. So we're going to take 2x plus 15 plus x plus 20 plus 3x plus 25 and set that equal to 180 degrees. First thing I'm going to do here is combine my like terms. So 2x and x and 3x. That's going to be 6x. Then we'll take 15 plus 20 plus 25. And that's going to give us, let's see here, $60. Subtract 60, divide by 6, and we're going to get here that x is 20. So then the next thing is they want to know what each of the angles are. So we're going to take this x that we have, and we're going to throw it in to each of those expressions. So for that first angle, it'll be 2 times 20 plus 15, which would be 55. Then we'll have 20 plus 20, which is 40. And last, 3 times 20 plus 25, which is 85. So the angles here in order from smallest to largest would be 40 degrees, 55 degrees, and 85 degrees. For number 9, so 9 is going to be kind of like that one we had with the transversal. There's kind of a lot going on here. So when I look at this picture, the first thing that my eyes go towards are right here, because I know that this little box is 90 degrees, which tells me that this side is also 90. So if that side's 90 and 40 is already used up, angle 1 would be 50 degrees. Okay, now the next place I'm going is, and there's lots of choices here, but the next thing I noticed was actually this triangle. And as I was on the hunt for the triangles, you guys, I just kind of was noticing it as I, trying to make other ones, that I didn't have enough information. So when I stumbled on this one, I do know that, I got one angle that's 58, I got one angle that's 90, and then I'm being asked for the third. And I know how to do that because if I add them all together, they should equal 180. So we're gonna take 180 and we're gonna subtract 58 and we're gonna subtract 90. Of course, you guys, there's lots of different ways that you could actually write the math I'm doing, So 58 plus 90 and then subtract would probably actually be more appropriate. But this gives you 32 degrees for angle 4. Okay, so now what do we want to find next? I kind of think, I'm looking at the same kind of idea, the same triangle idea, looking at these big guys, and this time I'm coming over here. So now for this one, I know this angle is 40. Up here's angle 5, that's what I'll be asked to find. And then this angle down here, even though it's not written, I can find this because I know part of it's 60 and the other part's 32. So this entire angle is going to be 92 degrees. So kind of the same deal. I know it's 180 total. I'm going to get rid of the angles I already know I'm using. So if we do this subtraction, I get 48 degrees for angle 5. All right, moving along. Okay, so now I need 2 and 3, and I'm kind of doing the same thing where I'm looking at my triangles, and it really wouldn't matter which way I started with this because I'm going to have enough whether I want to find 3 first or whether I want to find 2 first. So I'm looking right here at this guy, and kind of the same thing we've been saying all along. I know this angle is 48. I know this angle right here is 60. I can find that third one. So this will be 180 minus 48 minus 60 do that subtraction and you get 72 degrees. So this guy is 72. Okay, now these two together, 2 and 3 together, they make a line, so they also add up to 180. So this would just be 180 minus 72. And that tells me angle 2 is 108. So I've got them all except for there's one exterior angle here. It's right here. It's angle 6. And so for this, I'm kind of focusing really on this line. So this line is made up of 3 angles. So angle 6, this 60 degrees, and this 32 degrees. Now I crossed it out, but if you remember, we already did the math right here where we said all the way across was 92. So again, that's 32 plus 60 gives you 92. So 6 is going to be 180 minus 92, and that's going to be 88. So there they all are, hopefully 1 through 6. So there's 1, there's 2, there's 3, here's 4, 5, and then 6 over there in black. On to 10. So on 10, we're solving for variables here. So same idea, we're still kind of leaning on the fact that we know there's 180 degrees inside triangle, 180 degrees if you have a linear pair. So let's go ahead and start with, I'm going to look at this triangle right here and see if there's enough for me to find x first. So I could find x, but I would have to know what that angle is right here. And I do know that this would be 80 degrees. And again, that's because I have a linear pair. So 80 plus 100 is 180. So then inside this triangle, I would say 30 plus 80 plus 5x would equal 180 degrees total. So combine your like terms, 110 plus 5x equals 180. Subtract 110, 5x equals 70, and then divide by 5, x is 14. Now over here for y, same thing. There's the triangle, so it'll be 4y plus 40 plus 100 equals 180. Combine your like terms, so 4y plus 140 equals 180. Subtract and divide to get that y is 10. Now for 11. So on 11 here, you'll see that you have an exterior angle hanging out right here. So just remember, exterior angles equal the sum of the remote interior angles. So this one is just 70 plus 30. So x is 100 degrees. 12. So on 12, notice that you have these hash marks. So this is about your isosceles triangle. In an isosceles triangle, the base angles are the same. And then those sides are the same. So for this one, we're actually only asked to find x. So x is going to be 15. 13, though, is hitting that angle relationship. So I can tell it's isosceles because it's 10 and 10, which then tells me that these two angles are going to be the same. Okay, so 180 degrees inside a triangle. 64 degrees is already being used up by that vertex at the top. That leaves 116 degrees to be split evenly among those two angles. And that's 58 degrees. So x will be 58. 14. Still isosceles, because I see that these two angles are the same, which is going to tell me these two sides are the same. So knowing that those sides are the same is really the only way you're going to get through this. So now I know that those side lengths will equal each other. So I'm subtracting 3. I get 15 equals 3x. Divide by 3. X is 5. 15, we're back to the angles. And so since we're back to the angles, I'm thinking about this whole, add up to 180, or the fact that it's isosceles, which tells me that these two angles are going to be the same. There's a lot of ways to do this one. I'm going to go with the fact that when I put those little loops in, I was telling myself that these angles are the same, which makes this guy up here also 3y. Now that I see that, I'm going to go ahead and say that if I add all three of those together, I'll get 180. So that'll give me 6y plus 30 equals 180. Subtract 30. 6y equals 150. And then divide by 6. And y is going to be 25. So like I said, there's a lot of ways to do this. One of the things you also could have said is kind of like we did in 13. If I'm using up 30 degrees, I could have said 180 minus 30 is 150. And that has to be split up among the two angles at the bottom. So if you take 150 and you divide it by 2, that's 75. So that means that 3y would have to equal 75, and you get the 25 out that way also. So whichever way you feel like you can replicate is the one I would stick to. Now for 16. So 16 is asking for angle DBA. So following here, there's D, there's B, there's A. We're looking at this little angle right here. So for that, you'll see it's still an isosceles triangle. I would kind of say though on this one though, I'm noticing that I have a right angle here as well. Like if there's one on, on this side, then there's also one over there. And then that's just a missing third angle. So I can take 180 degrees, and then I'm going to have to get rid of the stuff I know. And if you do that subtraction, you get 15 for the measure of angle DBA. Lots of different ways to do that, like I said. And then I'm going to note right here, I've been writing it like this so that you can see sort of the thought process, but on the teacher side, I feel like what we say a lot is, well, let's add together the ones we have and then subtract that off of 180. So I'm writing it in a different way, but just know that it of course works here with what you see in blue.